Example 1, we're going to use the TI-83 or 84 and Desmos to choose a good viewing rectangle. So we're going to draw the graph of the function f of x, which is equal to x squared plus 3, in each of the following viewing rectangles. So the first one here, what we want to do is we have our screen. If we turn our screen on for our calculator here, we have our screen. And what we want to do is we want to graph this function. So we're going to go and select y equals. And then the y1 equals is the same thing as f of x equals. So we're going to put in the right side of this equation and type in x squared plus 3. So we can choose the button here and put in x. And then we're going to square it. And then we're going to add 3. Now the next thing we want to do is we want to change our windows. So that for part A, -2 represents the x minimum here on the left, and then this +2 represents the x max. On this side, -2 represents the y minimum, and this +2 represents the y max. So we're going to select window, and we're going to come in here and we're going to change our number. So we're going to change it to -2 for the minimum, and then +2 for the max. We're going to keep the x scale at 1, and then the y minimum is -2. And the y max is +2. We're keeping the scale at 1 and then the resolution. Now we're going to go ahead and select graph. Okay, now there was a line up here that was basically saying, okay, let's take a look at this. And once it's done, this is your graph. Now what you notice about this graph is that nothing is graphed here, which means that in this scenario, when we're using the minimum and maximum of -2 and +2 for both x and y, this is the viewing that we get. Now, let's go ahead and do the same thing for part B, and let's see what happens. So all we need to do now, the equation is already in there, so we're going to go ahead and go back to the window. And now we're going to change our minimum now, our x minimum now is going to be -4, and then the x max is +4, keeping the scale at 1 for x. And then we have -4 for the y minimum and +4 for the y max, and then keep everything as 1 here for the scale and the resolution. So let's go ahead and graph that. Now when we graph that, you should see that at the top part of this graph, there is a parabola. Alright, so we can see that we can see a little bit of it. Now, let's take a look at the next one, which is -10, 10, -5, and 30. So let's go back up here. We're going to go back to window again, and then we're going to change our dimension. So the x minimum is -10. The x maximum is +10. The y minimum is -5. And the y max is +30. And then we're going to keep everything else as 1. So let's go ahead and graph that. Now when we graph that, we can see a better picture of the parabola of this graph. So that represents that one. Now let's take a look at the last one. So again, let's go back to the window, and then we're going to change the x minimum to be -50. X max is +50, and then changing the y minimum to -100 and the y max to be 1000. Now we're going to go ahead and select graph. And so here, what we've been able to do is we've been able to see the viewing rectangles of each of these graphs. Now let's go back to the function, which is x squared plus 3. We know that the domain of this function is all real numbers, which goes from -infinity to +infinity, because we can plug any number in for the value of x. Now, what is the range of that function? If we look at the range of the function, it's going to start at 3. So that means it's going from 3 to infinity. which means that this first window tells us that there's nothing in there because this is outside of that window, which is -2, 2, -2, 2. Now, the one thing we need to look at is graphs B, C, and D. What do we notice about B, C, and D? Well, if you take a look here, the y-intercept is the value of 3. So we can see that the y-intercept is 3 here. We can also see it in this graph as well. However, if we look at D, it's really hard to tell whether that we can see that the y-intercept is 3. So the best choice that we're looking at is probably B and C as a clear picture of what we want to see. So again, you can look at this question to determine, what is the best window to look at when you're looking at a graph. Now we can also do the same thing using Desmos. So let's go ahead and put that in there. So we're going to put in x squared. So down here, you select the keyboard, you got x squared, and then put +3. Okay, so right now, the viewing window doesn't show us what we want to see. If we want to change the viewing window, you see this wrench up here on the right where it says graph settings, we can do that. And then here where it says you have the grid, you can have the grid on, you can turn the grid off. You can add axis numbers. You can put arrows if you want at the top. Now, on the x-axis, what we want to do is we're going to put in our window. So we have -2 for the first one, and then it was +2. And then for the y minimum, we had -2 and +2. So as you can see here, we have the same blank screen as we did in part A. So very similar to what we've seen there. Now, if we want to go to the next viewing rectangle, we can do that by then changing the dimensions to -4, and then +4, and then -4, and then +4. And so again up here, it might be a little bit easier when you're using Desmos to immediately see what the y-intercept is just by clicking on that point. Whereas on the TI graphing calculator, you have to hit the trace button to look and see where that's at. So therefore, now we have our viewing window for the part B. Now let's take a look at part C. Again, part C, we have -10, and then +10, and then -5, and then 30. So now we can see the parabola in a much better, clearer way. Again, looking at the y-intercept. And then if we take a look at the last one here, again, select the wrench here. We're going to go ahead and put in -50 and then +50. And then we have -100. And this goes to 1,000. So again here, it's harder to see what the y-intercept is, but if we click on the button, we're still able to see it. So again, this is viewing rectangles using a graphing calculator, either using the TI-384 or Desmos.